Hello, calculus fans. We're going to create this piecewise defined function. So f of x will be equal to sine x, as long as x is less than 0. It's equal to x squared plus 1 if x is between 0 and 2, including 0. And it's equal to 7 minus x if x is bigger than or equal to 2. And I'd like to use the graph of this piecewise defined function to determine the values of a for which the limit as x approaches a of f of x exists. Now let's go ahead and take a look at a graph. So here's what the graph looks like. So it's broken up into these pieces. Now it's pretty easy to believe that as long as a is not 0 and a is not 2, the limit exists. So if you go from the left or you go from the right at any other point, you're definitely going to get the same value. As we go along, we're going to actually run into this as a property that we'll be discussing. It's called continuity. But there really is some question about what happens at x equals 0 and x equals 2. That should make sense because those are the breakpoints in how we've defined the function. What I'd like to do is check left and right hand limits at each of those points. Now at x is equal to 0, the limit as x approaches 0 from the left of f of x is equal to 0. If we go from the right, it's equal to 1. Those one-sided limits do not agree, so the two-sided limit does not exist. Let's see what happens at x equals 2. The left-hand limit will be 5, and the right-hand limit will be 5. I'm gleaning all this information from the picture. This time, our one-sided limits agree, so the limit as x approaches 2 of f of x exists and is equal to 5. All right, so our final answer is that the only value of a for which the two-sided limit doesn't exist is a equals 0. So the limit exists for all values of a except a equals 0. Okay, that's all for now.